Good day. My name is Kealey Ruhaya, and I will be taking you through the project that I made, the game that I made for artificial intelligence. It is an AI snake game using reinforcement learning. So, in this presentation, I will be taking you through an introduction of the agent. I will be taking you through the user interface overview. I will be taking you through the sensors and actuators that we used in this project. I'll then be taking you through the methodologies that were used to create this game. And then I'll be taking you through the implementation tools that were chosen to be used in this project and why I chose to use this in my project. So in this project, I created a snake game that uses artificial intelligence and reinforcement learning. So in the game, the agent plays the game itself. There's no user input from any user, and it learns through trial and error. It learns what the goal of the game is and an efficient way to play it. Um, so the agent in this project perceives its environment. So the environment being the position of the food for the snake to eat, and the walls, because if they run into any walls, the game ends. Um, so the decision making process, when the agent wants to make a decision on what action it should take, either left, right, or straight, it uses either exploration or exploitation. So, exploration, it would take a random direction and just go in that direction, and exploitation, it would predict the best direction to take based on the inputs that it got. So the agent continuously learns how to play the game and how to play the game efficiently. So the agent was designed so that it could collect as much food as possible. So that is the main goal of the agent. So the overview of the user interface. Pygame was a library that was used to create the user interface. So Pygame was used to display the window, set the background, draw the food and the snake. As you can see in green is the snake trying to get the brown food, and it also updates the display. As said before, there is no user interaction needed for the game. So now we'll go through the sensors and actuators that are used in this project. So the sensors help the agent understand the environment that it's in. So the sensors that we used in this project are first of all a danger value. So this is a value that represents whether there is danger for the snake around it. So to the left, in front of it, or to the right of it. So types of dangers would be like a wall, because if they run into any of the walls, the game ends. So secondly, there's a direction value. So this value is just a value that indicates which direction that the snake is moving in currently. The other value is a food value. This is a value that represents where the food is on in the environment to help guide the snake to the food, which is the actual goal of the game. So then the actuators are they help the agent to take action. So the movement of the snake is one of the actuators that is either predicted by the model or a random action. And then once that action is taken, the actuator's task is also to update the snake's position. So now we'll go through the methodologies that were used to complete this project. The network that was chosen to complete this project was a feed forward neural network. It is a simple network with three layers: an input layer, a hidden layer, and an output layer. So, in the input layer, it takes in the sensors that we just talked about. Um, the sensors being the danger values, the direction values, and the food or reward values. So, it takes that, it sends it through the hidden layer, and in the output layer, a predicted action that the snake should take is outputted. So, what it thinks the best action is to take, that's what outputted in the output layer. So once that is done, we have to train the model. So we train the model using Q learning. So the way that the model is trained is first that the Q value is firstly initialized. Once that is done, the next action is predicted or a random move is used. So this is now speaking on the exploration or exploitation. So um, either a predicted action is taken or it will explore the environment and just go in a random direction. So then the action is performed, and based on the results of the action, whether it was a good action to take or not, we can update the Q value, and that's what will train the model. So now I will be taking you through a demonstration of what the game looks like and how it is played. So now I'm going to start the game. So what you will see is the agent trying to figure out what exactly the goal of the game is. As you can see now, we are on game number 14, and it still hasn't gotten a first taken any food. Now it has, and usually in the first few games it won't um, know how to play the game properly, but it will learn how to play and the most efficient way of playing the game. So I will now fast forward and come back in 5 to 10 minutes to see what the difference is once it's learned how to play the game. So after 10 minutes, now you can see that the model, the agent is doing a lot better than how it started. So you can see by the results on the left, the the average has increased. The average amount of times that it actually gets the food has increased, and you can just see by the gameplay that it has an understanding of what the goal of the game is, and it's to retrieve as much food as you can. So, some of the tools that were used to implement this system was firstly Pygame. Pygame was chosen because of its efficiency with creating games, user interfaces, and also handling the graphics of the game. So another reason why I chose Pygame is there are many resources to help if and when I did go find any errors in my code, there are many resources that can help fix the problem. The second library that was used is name tuple. Name tuple was used to create an object to represent the x and y coordinates in the game. The third library that was used was NumPy. So NumPy is a widely used library for numerical operations, and that's why we chose to use that library. So all in all, I think this project achieves the goal that it intended to. It shows the development of an intelligent agent-based game using reinforcement learning, and shows how it learns how to play the game Snake. Thank you for listening to this presentation.